Okay, now we've got another type of equation, a radical equation. Okay, so we know this is a radical equation because this radicand right here, or the radical, I'm sorry, radical symbol, the radicand is what's inside. So this is a square root. Now, how would we get rid of it? Well, to get rid of the square root, you naturally square it. A square gets rid of a square root. But what you do to one side, you must do to the other. So we square both sides. All right, and now we're on our way. We've got x plus 3 on the left-hand side, but the right-hand side is, you guessed it, a binomial square. So this is a minus b squared. So I'm going to do this really quickly, but if you've got any questions, I've got a video on special products, and I'll try to remember to put it in the link at the bottom. But special product here, a binomial squared, and I'm just going to expand this really, really quickly. X squared minus 6x plus 9. Okay, now we're going to combine like terms. Minus x minus 3, move that to the other side, and we end up with x squared minus 7x plus 6 equal 0, something that I can factor very, very quickly. The factors of positive 6 that add to give me negative 7. What are those? X minus 1 and x minus 6. Set it equal to 0. 0 factor property, x equal 1 and x equal 6. So we've got two answers, but that does not mean that this is the answer, or these two are the answers to my radical equation that I started off with. What I have to do is I have to check both. In the case of a radical equation, when you square, in this case, that was the operation that we did. When you square, if it was cubic, when you cube. But what we've done here by solving it in this method is we've introduced the possibility of an extraneous solution. So an extra solution that actually doesn't even work. So that's why I say we have to check our answer. So let's first check x equals 1. That's the first case. The second case will be x equals 6. Now there is the possibility that this can have no solution at all, but let's find out. Let's see. We're going to plug in 1 into the original equation. So the square root of 1 plus 3 should equal 1 minus 3. And what's the square root of 1 plus 3? It's the square root of 4. And what's 1 minus 3? That is negative 2. And the square root of 4, the principal root is 12, or I'm sorry, 2. And that we know does not equal negative 2. So this is where I'm telling you, okay, we've introduced an extraneous solution. So we know this is not the case, and x cannot equal 1. But we shouldn't just give up and say, oh, well, then x equals 6, because remember, there's the possibility that 6 may not work either. So we need to check that as well. Let's check. 6 plus 3 should equal, or the square root of 6 plus 3 should equal 6 minus 3. 6 plus 3 is 9, and that should equal 3. Square root of 9 is 3, and 3 equals 3. This one checks off. So x equals 6 is actually our only solution for this radical equation.